Okay, there we go. There's good old Euler. All right, so we're going to talk about Euler's method and how is it used. This is not a super difficult thing. It basically combines the point slope kind of form of the line a little bit. It's similar to that. It's similar to something called linearization, which we kind of touched on last year. And then it's cranking through numbers. So you got some derivatives involved in here, all right, and using some functions. And that is good old Leonard Euler, okay? So what we're going to do is we're going to open up our textbooks, okay? So open those things up. That's what those brown things are, is your textbooks, okay? Find page 408, all right? All I want you to do, okay, again, at some point, you're going to have to go to college. You're not going to have Mrs. Ballard anymore, okay? I won't be there, all right? No, I can't. Right? I will not be there. And you're going to have to possibly open up your math textbook and actually read it. So when we do this, it's not that, I'm trying to help you get there, okay? So what I want you to do is I want you to read from the red where it says Euler's method all the way down to the top of where it says example 6. I'm going to give you about 3 or 4 minutes to read that, so we're not talking, everybody's reading. Got it? All right. So do I. That's why we're taking calculus, right? Because we hate reading. All right. Yeah, don't talk, read. Okay, I shouldn't hear talking, I should hear reading. About another 30 to 45 seconds to finish reading that section. You may, if you're done, you may even go back and skim it again. Typically when I read math, I have to read it 4 or 5 times, so it's not unusual. Okay, so what we were doing yesterday was we were basically trying to calculate that extra c value, right? We were calculating the particular solution. Euler's method is another way to do that, okay? What they do is they give us a starting point, and that's what the reading said, is there was a starting point, okay? And then they give us a step size. And the step size is basically, it's your dx, okay? The smaller that step size is, the better the numerical approximation is, all right? But you build everything off of the initial point that they give you, okay? And then they're going to tell you either where to stop or how many steps to do. So we're going to do kind of one of each type, and then I have a homework assignment. There's only 2 examples. They're not super long though, okay? Even though they look like they're going to be long on the paper. All right, I think you got to fill in some stuff, right? Yeah. So take a minute and fill in some stuff about the linearization, okay? So yours says linearization, just write number 1. Linearization approximates the value of y using one tangent line. And Euler's method uses many tangent lines. Okay, and then you might want to write down, and then that equation gets written down. So it's this thing here goes in the first line, this one here goes in the second line, and this is the equation you need to write down. Okay? Alright, so linearization is basically what we call a tangent line approximation. Okay, we did that last year. You might not remember it, but we did do it at some point. Okay, so basically instead of using one tangent line, Euler's method uses a whole bunch of tangent lines to get to that C value. Alright, this is the formula we're going to use. Alright, so to approximate whatever the value is, okay, we take the point we had initially, we add that to the derivative of whatever the function is, and usually they give us the derivative, and then times the step size. So that there is going to be the step size that they give you. It's usually a decimal point, like 0.2, 0.4, something like that. All right, so let's try a couple of these. All right, again, that formula that I'm going to write the formula up here at the top so we're looking at it. I know you have it on your paper, but I don't have it on mine anymore. So y of a plus the derivative of f of a times dx. Okay, so they give me the derivative. The derivative is right here. Okay, this is your initial point. There's your step size. What do they want us to approximate? 1.3. Where are we starting? 1. Okay, so I'm starting with 1. Get to the right one here. So I'm starting with y. So this is how I set up. Y of 1 equals 0. What's the step size that I'm using? 0.1. So my next one that I would calculate would be 1.1, wouldn't it? What would come after 1.1? 1.2. Notice I'm leaving space in there. What would come after 1.2? So that would be where I'd stop. So I have 3 steps that I have to get through this time. Okay? All right, the next thing I'm going to put in is my previous value. So my previous value is 0, right? So either if I'm going to write out the actual work, I would say y of 1, which on my next line I would write equals 0. Plus, they want me to find the value of the derivative evaluated at 1 times the step size. So that's filling in this formula. Now I'm going to go ahead and do the calculation. I said y of 1 is 0. We need to look at f prime of 1. Do I have a value for f prime? Could I calculate it? They gave me the derivative. That's your f prime, right? I have to plug this x and this y into it. So I plug in what for the x? 1. Good, that's the x. And what am I going to plug in for the y? So I basically have 1 times 1, which is 1. What's the step size that I have to put in? 0.1. So what is this one equal to? Just 0.1, right? Okay, so let me explain it again, okay? So, the formula says I take the y value, okay, or the previous value. So that was my previous value. It got plopped in there, okay? That's what all of this was about. This is notation in this line, right? It's not the problem, it's notation. This is the calculation in the second line. Then it says take the derivative of whatever the value is that we had, but that we were plugging in from before. Okay? So I took that derivative, I plugged it in up here. Right? So once I plugged that derivative in, I calculated that it was 1. I had to use this point here. Okay? Then it said multiply by the step size. My step size was 0.1, so that's where the 0.1 came from. When I did the calculation, I got 0.1. All right, so I'm going to highlight that 0.1. let's do the calculation again. Okay. So, oops, I don't want the highlighter. I want the pen. Okay, so the next one would be I'd put in y of 1.1, so the previous value, right, times f prime of 1.1 times dx, which in this case is 0.1 every time, right? Okay, so that's the formula I'm filling in. Do I have to necessarily write the formula every time? No. Okay, I'm showing you where I'm getting it from today. All right, but you could probably just crank through the work. It's the previous one. Okay, so it comes from the A comes from the previous one. It's like when we did recursive sequences. It's similar to that. Okay, when we did those way back in Algebra 2 somewhere. Okay, all right, we're going to take this and it gets plugged in, right? So 0.1 gets plugged in, plus, where do I plug this? Plug the 1.1 into? We're plugging into here, but we're plugging in 0 for the... no, wait, no. We're plugging in 1.1 for the x and 1.1 for the y. Does that make sense? Okay, because I have to plug in 1.1. What's the y value for 1.1? Yeah, so the value that we are plugging in, we know that that's the point, right? So I have to plug that into this thing here. So when I put in for the x, I'm putting in 1.1. For the y, I'm putting in 0.1. Okay, so you guys have a calculator. If you can't do it in your head, use the calculator. What are we getting? Good. And then we're multiplying by the step size. What's the step size still? 0.1. All right. Use your calculator and get an answer. 0.099? I want the final answer. Do we agree with Kaylee? You agree? Are you sure? So now I have, what? This was the x value. This is the new y value. Do we see it now? Okay. What's wrong?
I'm so confused how you got
0.99. So I took this x value and that y value, and I plugged them into that. Okay, make sense? Okay, once you get used to the pattern, you guys, this is a pretty easy thing. Okay, they've tended to like this in the past. You just got to learn the method. Okay, not forget it. So now, if I'm going to go back into this formula here, I'm going to do y of what was my previous x value, 1.2, plus the derivative of 1.2 times the change in the how come I can't remember the word now? The dx, okay? All right, the change in the step size. All right, so what was my previous y value?
1.2.
Nope. Previous y value was 0.199 plus, remember we're now going to take this for the x, this for the y, and plug it into that right there. Okay, so I've got, what am I putting in for the x? 1.2. I'm doing scratch work off to the side. 1 minus 0.199. Use your calculator, figure out what that is, and that's the number we're going to plop in here. 0.9612. Do we agree with Kaylee? Are we sure? Okay, what am I putting in for the step size? 0.1. Good. Now go ahead and do the calculation. What do we end up with? The 0.1 is the step size. It's the dx. Okay, is everybody okay with where the dx is now? All right. Notice that 0.1 was consistent on all of them, right? The step size didn't change. It will always be consistent like that. All right, what do we get for the final calculation? 0.295. I got 1, 2 after it. Does it matter if I put more than 3 decimal places? No, as long as you're accurate up to 3. Okay? And remember, in the middle, if there's more decimal places that come up, use all of them. All right? Okay, that was the first one. So that's one way it can be presented. The second one is another way it can be presented. All right. Let me take a sip of water. We'll do the second one. All right. So I'm going to write the formula up again. Okay? It was y of x equals y of a plus f prime of a times dx. So that hasn't changed. The way they phrased the question has. Do we have the derivative function? Isn't that what y prime is?
Yes.
Okay. Instead of them saying f of 2 equals 5, they gave us a point to start with. So gave it to us in point form versus function form. All right? How many steps am I going to do? 2 steps, and they want me to land at 2.4. So where is the x value that we're starting at? So I would probably rewrite it as f of 2 equals 5. I know somewhere down here in 2 steps I have to get to 2.4. What's in between those two? 2.2. So did they give me the step size? Did they give me the dx? No, but they told me how many intervals. What is the dx value? Look at how much difference there is in between there. 0.2 is your step size. So on this, the way this one was phrased, we had to calculate it. Okay, but it wasn't that hard if we kind of logically went there. All right, I'm not going to write all the extra formula. I'm just going to write the numbers this time. Okay, I hope that might be less confusing. So I take the number from before, right? This one here says I got to take and plug these numbers into the derivative. Is there anywhere to plug the y in?
No.
No, just the x. All right, I gave you a very complicated one at the first one. So when we plug that x in, what's 2 times 2? 4. What's my step size? 0.2. All right, calculate it on your calculators. We all agree with Cody? You beat Kaylee to it this time. All right. So I'm going to do this same pattern again. What's going to go first? 5.8. Good. Plus, what do I have to plug in this time? 2.2 technically with that y value, but we only need the x. So when I put 2.2 times 2, what do we get? 4.4. Good. Times, what's the step size? 0.2. Are we sure? It's not what I have written down. Double check. Do we get 6.68? We good? That's it. Can we handle this today? I didn't feel the need to do a million of them. Okay? I'd rather you get started and try it a little bit on your own, and then if you need some more help, I'll help you. Okay? So, the homework tonight is the Euler's method worksheet. It's in your notes. Do you see it down there under example 2? Are you going to do it in your notes? No, you're going to put it in your spiral notebook. Okay, so everybody right now, everybody's going to get that out and working on all of 6 problems, right? All right. Hit keep. So right now you are doing that.